Hello gentlemen, welcome back. The purpose of this video is to talk about inverse functions. I'll give you a quick introduction to them and get ready to actually move forward and actually find inverses in the next video. We're going to use the idea of composite functions. So if you struggled at all with those, please either email me or go back and watch the previous video, as they'll be important as we move forward. Okay, so let's get started. The idea behind an inverse function is that two functions are inverses. Basically want to think about that as one function doing something to our input value. For example, in here we have a composite function. I plug in some value x and g performs some operation on that value of x. F is then going to perform an operation on the result of that, which is going to bring me right back to where I started, right there back at that x. Okay, so let's do an example. Simple example here. If I go f of x is equal to x plus 4, and if g of x is equal to x minus 4, and I want to show that those are inverses of each other, I look at the composite function f of g of x. We know how to do this. We did this in the last section. Wherever I see an x in the f of x equation, I plug in g of x. So I'm going to get x minus 4 plus 4, and if I simplify, I get x. Okay? So that shows me that f and g are inverses of each other. So what g of x did was subtract 4 from the original value. F of x then added 4 back, and I get back to where I started with x. It works the other way as well. I can say that g of f of x is equal to, now wherever I see an x in the g of x, I'm going to plug in f of x. So I get x plus 4 minus 4, and again I'm going to get x. Okay, so that's satisfying this idea of composite function. I get back, I just undo what the original function did. Okay, and we're gonna pay some attention to the domain stuff. That's going to be important, but there'll be a little bit more on the other video. So let's continue on here. Let me get this out of the way here. And what we're going to see here, let's bring this next part of it up, is that for inverses, we denote it f inverse with a -1 subscript up there. Okay, it's called f inverse. And a couple important notes, that if the point AB is on the graph of f, then the point BA is going to be on the graph of f inverse. So this is an important concept, fellas. This idea here is that the domain and range of the function f becomes it switches. The domain of f becomes the range of f inverse. The range of f becomes, the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. We'll see that in a second. That's a little confusing. Let's look at it visually. Okay, the domain of f here this is the domain of f, and this is the range of f. Okay, so we take some value x, it gets mapped to f of x in domain and range. You guys understand that. Now what I want you to understand is this set over here, this range of f becomes the domain of f inverse. And the range of f inverse is actually the domain of f. And everything's going to get flipped about the line y equals x. Okay, again, I know this is a little bit confusing, but understand this. The domain of f is the range of f inverse. The range of f is the domain of f inverse. Okay, I'm going to repeat that several times. Here's a visual of it. Here's the line y equals x. The graphs are reflective about this line. Okay, the point AB is on the graph of f. The point BA is on the graph of f inverse. Okay, remember that again. I'll say it again. The domain of f of x is the range of f inverse. The range of f of x is the domain of f inverse. All right, so just understand that for inverse functions, the domains and ranges switch. Very important concept. Let's look at an example. I want to show that two functions are inverses of each other, and I have this on x is greater than or equal to 1, and we'll see why in a minute. Okay, if they're inverses, we want to show that the composite function should just equal x. So f of g of x should give me x. Let's see if that happens. So f of g of x is f of x squared plus 1. Wherever I see an x here, I got to plug in x squared plus 1. And if I do that, it simplifies to x squared plus 1 minus 1. The plus 1 and the minus 1s are going to cancel each other out. I get the square root of x squared, which we know is simply equal to x. Okay, that worked. What about g of f of x? That means we have g of square root of x squared minus 1. So wherever I see an x here, I'm going to plug in the square root of x squared minus 1. If I do that, you should see that this square root's going to go away, and then the minus 1 and the plus 1 are going to cancel, and again I'm just going to be equal to x. Let's look at the domain and range of the function f. The domain here, because I have a radical, the domain of this function is going to be from 1 to infinity. If I plug in anything less than 1, this is going to give me a negative in the radical, and we know we can't have that. Okay, so my domain is 1 to infinity. My range here, I know I'm going to produce all values that are greater than or equal to 0. Now, again, let's go back to what we said before. The domain and range have to switch. And we're going to talk a little bit more about this in the next video. But just to understand this concept, how they're switching. The domain of g of x, the inverse function, is going to be the range. So I'm looking at only on 0 to infinity here. Even though this is defined for all real numbers, for this inverse part to work, the range of this function here is got to be the domain here. Okay, and you're going to actually see that we have to limit the domain of this function in order for it to have a limit, have an inverse, and you'll understand that in the next video. But just get this concept down now. The range of g of x is going to be equal to the domain of f of x. Okay, so again, they're just switching. Let's see what that looks like graphically. Here it is. You can see that the domain of f of x is going from 1 to infinity. Look at what the range is here. The range here is going to go from 1 to infinity. You can see that the range of this is going to go from 0 to infinity, and you can see the domain of this function is going from 0 to infinity. So you can see that they're switching. All right. Again, hopefully you guys understand that part of it. Here are some practice problems. I'm going to have you read the whole section 1.9 and particularly pay attention to those two inverses. The next video will give you the rest of section 1.9. Here are some problems. These really shouldn't take you too long. These are just matching up some graphs and stuff. But to summarize, we talked about inverse functions. The two functions are inverses if they're composite. If f of g of x is equal to x, or g of f of x is equal to x. Basically, one function does something to a value of x, the inverse function undoes it, and we just end up back to where we started. Okay? Understand that inverse functions, the domain and range switches. So the domain of f of x is equal to the range of f inverse of x, and the range of f of x is equal to the domain of f inverse of x. I know there's a lot of wording there. It gets confusing. It'll take some practice. Again, if you have any questions, email me, and I'll hopefully be able to clear those up for you. Okay, fellas, have a good day.